All right, so some of you all have already seen this. Most of you all potentially already have worked with this. My apologies. And the idea is to be able to control the flow of data, being able to control the flow of data. And you've probably seen this, of course, in Python, but in R it's a little different. At least the syntax, it looks different. I mean, and the logic is the same. All right, so with that being said, let's go ahead and begin. So first concept we have to talk about is if, else, and else if. And so this allows us to control data based off of certain conditions. We can control the flow of data based on certain conditions. For example, let's say x is equal to -10, and we want it to have, or at least test, or at least determine the flow of what this actual output should be. So if x is greater than 5, we're going to say that's equal to 10. It's going to be positive. If x is equal to greater than 0, it should be positive. X is equal to 0, it should be 0. Else, otherwise it has to be negative. It has to be negative. So if you do x is equal to -10, it's going to print negative. If you set the x is equal to 10, it should be positive. Okay. And so with that being the case, you now have the ability at least to do this in R if you haven't done so already in Python. All right, so the syntax is not too crazy. With that being said, go ahead and take a moment and do this complex example. Just take a moment, just take some additional practice. If you already are a whiz, just still do it. Oh, okay. So with that being the case, okay, how I would set this up, okay. Leave my cord. Let me get my. I'm gonna say that you're gonna have score. You're gonna have the score, and so if it's greater than or equal to 90, it's A. If it's between 80 and 89, it's a B. So on and so forth. So what I'm gonna do is I'm gonna do an if. Okay. Score. Mind you, we haven't defined what score is, but we'll define it in a moment. If it's greater than or equal to 90, okay, we're going to define this within curly braces. Okay, I'm just going to put the character A, okay. Else, if score is greater than or equal to 80, it's a B. So logically, you're supposed to say, hold on, but wait, don't we have to say in between 80 and 89? But the idea is that if it's already above 90 or above, it's going to be an A. And so it's going to go through this sequentially. First statement, then the next statement. First if, then the next else if, then the next else if. So if it's greater than 80, then we already know it's going to be it's going to be a B, which it's only going to be between 80 and 89. And if it's not greater than 90, if it's not greater than 80, then it's going to do the next check. Does that make sense? Okay, so let's go to the next check, and I'll explain that in a moment again. So we're going to then say else if. You got to go up to C. Okay. I'll just finish this. Else if score is greater than or equal to 70, you're going to give it a C, right? Right? Let's just move it like this. Same logic. And then the last thing we have to do is just else. We got else is going to be an F. Okay. So the thing is, assuming that we're getting the score to be a number, the score is a number. If it's greater than 90, it's going to be an A. Then if it's greater than, once we determine that, we're good. If it's not greater than 90, it's going to go to the next check and say, okay, is that number greater than 80? If it's greater than 80, it's going to be a B because I already classified everything that's above 90. If it's not greater than 80, it's going to go to the next check. It's going to check if it's greater than 70, okay, which is in between 70 and 79, because anything above 79 has already been classified. All right, so let's now check this out. I mean, we all know this is going to work. Score is going to be 30. Oh yeah, because I don't know why I went so low. It shouldn't print actually. I think Oh, it does print. Okay. And let's say you get a 95. Aim high to the sky. Okay. Okay, good. That's that. Let's do a few more. So which, when I first learned R, I used which a lot. And this is like a key indicator before this class, at least before this week. If you use this, it's like you definitely use ChatGPT, because I want to use this function. As this is really, unless you're doing software nowadays, it's as if you're doing software development within R. And I used to do that as a kid, or at least when I was your age. And that's not a good idea. So I would argue you should do software engineering or software development within Python or another language, not R. R is a statistical programming language. But it still has the capacity nonetheless to work with data. And it's kind of like a filter. Okay, so it's like it's checking, it allows you to check a condition on a number or on elements, so not just a number, based off of a certain condition. And so here, what we can do is say, okay, fine. Okay, the values are -10 and 15, so on and so forth. If it is, I want to check if any of those numbers are positive or negative. And what I can then do is run this, and it's going to give me the actual indices, right? Okay, indices at which you actually find those negative numbers. Okay, does that make sense? Hopefully, it just provides you the indices. One could argue, I prefer me myself. I guess this function exists. I would prefer the filter function, because it gives you a Boolean true or false. All right, but this gives you a step further to not only just tell you if it's true or false, but gives you the actual indices. Okay, so if you wanted to say, okay, fine, I want to find those numbers that are positive, or I can say then again values positive indices, which should then give me those actual set values. Okay, why don't you take a moment and then do this actual example, or at least this this complex example. All right, so I'm gonna do it for you. I'll do it with you, something like that. And we're gonna do the following. We're gonna say data. Because what's the question? Filter, use which 18 or older. So data $, and we have, sorry, wrong. We haven't mentioned too much about using $. I think you probably might have seen me do it once, but it allows you to get access to the actual columns within the data frame. So data ages, right, is greater than or equal to 18. All of them are. Geez, well, that doesn't really mean much. Okay, so all of them are true. Okay. But then I would want to find the indices. Okay. At which these are true. What did I do? Okay, here we go. Boom. 1, 2, and 3. You know what? For funsies, let's add Jack, and Jack legitimately is 15. Okay, so 1, 2, and 3. Okay, fine, good. And then what I would want to do is to specify in the row elements, the rows, the actual data frame that I'm actually the rows that actually are true based on this condition. Okay, and then I would finally save this as the adults, because there's greater than 18, and then run that, and then I will then print adults. That was pretty easy. That was pretty easy. Whereas data, this is going to show it on 2. That's fine. You see, data was 2 columns, and then adults is just 3. This is a little bit better using a filter, but then this is working with a data frame. But you can see the utility in it in terms of what you would want to do in terms of if you would do some level of software programming or development within R, which again I don't advise. Okay. Switch statements. Okay, switch statements. All right. So switch statements allow you to alternate between different expressions. It's useful for handling multiple conditions and executing different code blocks based on the value of a variable. I don't know why it's giving me these as if the code won't work. We're saving color as red, okay? And whatever, it's just a function based on the output, based on the input, provide a certain output. So if we were to say red, it ideally should say high. If I were to say blue, it would say unknown. If I would say orange, it would say medium, so on and so forth. So you can see how that potentially works. Okay, so that's just switch statement. Nice function. All right, so with regards to the switch statement, why don't we do this last example? Okay, this is fun, right? So we're going to do the switch statement. We'll say that color, what's that color? It's, right, R script handles the input switch. The program convert the string into the corresponding mapping. So I would say, I would want to say about switch, and the syntax is always, you know, different. And so I think the very first thing is going to be your expression or your input. Your input. So we'll say string number, I guess, okay, comma, if it's 1, we'll say it's 1, just because the syntax is similar. Boom. Syntax is similar. 2, 3, 4, 2, 3, 4. And I'm going to say invalid input. Is that what it is? Invalid input. Still not done. I need to change this to 4. I need to change this to 3. I need to change this to 2. And then I'll say string number is equal to, let's say 1. Not correct. 1. Okay, and then it should print out 1. Nice way to do it. This is a fast way of doing a conditional if you know it's going to be one of these 3 outputs, right? That's really nice. A little fast way of doing it rather than using if else like we did before. We could probably just use this, and it's easier to read, I would think. I think. Let's say we did I don't know, 10. Invalid input. Okay, so that's that. Okay, so that's it for this video. Thank you for watching. Even if you're a CS major, I appreciate it for watching this. Yeah, so that's it for this.